Hey guys, welcome to EOC Explain. Here we go. Alright, if you want to go over 45, pause and do so real quick. Otherwise, let's rock. Cold sores are caused by the herpes simplex type 1 virus, right? A company that wants to develop antiviral drugs would ask a research immunologist to study what? Alright, first things first, we got to highlight. So let's highlight a few things here. I highlighted cold sores. We'll go over what they are in just a second. The herpes simplex virus type 1. They want to develop antiviral drugs and then an immunologist, right? First off, what are cold sores? Cold sores are a type of herpes. So there's your revelation, right? So if anybody gets a cold sore, that is actually a relative of herpes, right? So what do they look like? Bam, that's what they look like. Usually it's on the lip. Okay, is it a type of herpes? Yes, we talked about that. So this company wants to develop an antiviral drug. That's what we highlighted. What does anti mean? Anti means like against, right? Or stopping in this case. So they want to develop a drug that stops or is against this cold sore virus. And they'd ask an immunologist. An immunologist is just someone that works with the immune system kind of deal, right? All right, so let's go through each of these answers and let's start crossing them off, and eventually we'll get to the right answer. All right, let's start with D. Meiosis in the virus. So they want to develop an antiviral drug, and then ask a research immunologist to study meiosis in the virus. First off, what is meiosis? Well, meiosis equals the type of cell division that makes gametes, right? Makes sperm and egg cells. Virus does not deal with sperm and egg cells, so that would be eliminated instantly. Virus isn't even a cell, so it doesn't even go through cell division. It gets something else to copy it, right? Let's go through the next one. They're going to ask a research immunologist to study what? Let's look at C, the metabolism of a virus. Well, here's the deal on this one. Viruses don't really do metabolism. They have the cell do it for them. They land on the cell, kind of like a mosquito, inject their DNA, sometimes RNA, and get that cell to make copies of them for themselves, right? So they don't even do any work. It's like walking up to a printer that's already going and slipping in your copy, and then it starts making your copies. You're not actually copying anything. You're just slipping in the blueprints. So they don't do metabolism. They're not technically living, so we can pretty much eliminate that one. All right, let's see. Let's look at B. They want to develop antiviral drugs, antivirus, against virus drugs. They're going to ask a research immunologist to study, let's look at B, how closely related the virus is to cold viruses. Okay, we're trying to develop a drug that hopefully will stop cold sores, right? They'll stop this virus. We don't care how closely related it is to cold viruses. That's irrelevant. We don't care. It doesn't matter. We want to know, we need a drug that will mess this virus up, right? So we can eliminate B. And let's talk about A real quick. So bye-bye B. All right, A says the mechanism used by the virus to infect cells. So we know that viruses, they're not really classified as living. They land on a cell, they inject their DNA or RNA, and they get the cell to reproduce themselves. They get the cell to make copies of this virus, right? So the only thing we need to block is how they can get into the cells. If we block that, they're worthless. They're not going to do anything. The virus is done at that point. So that one makes the most sense. We block the virus from actually getting in, be able to infect the cell. We're good. So A is the correct answer. So a company wants to develop antiviral drugs, would ask a research immunologist to study the mechanism used by the virus to infect cells, because we know they infect cells, right? So hopefully you got A. Have an awesome day.